In this question, we are looking at data that was collected and used to get a proportion of people who have access to the internet. So with this in mind right here, we need to first examine a question from chapter 15 and think to ourselves, is this actual real quantitative data or is it proportion data? As we can see, the question was answered yes, no. So this is in fact, as mentioned before, data that can be used as proportions. Now there are three conditions. It doesn't state in here what the three conditions are, but the three conditions for checking to see if the normal model is appropriate would be the randomization condition. That means that these people were randomly selected from each other. And we don't want to go out and select the first 560 people. We want to actually have random people selected that would represent all of the people who we could possibly survey in our population of interest. Also to mention, the parameter of interest for this problem is, do you have internet access? The population seems to be all U.S. adults. Now, with this in mind, the second condition is the 10% condition. The 10% condition states that we need to sample less than 10%, and that's less than 10% of the total population. So if there are 30,000 students at UT, we would want to sample up to 3,000. The reason for this is our estimates for the standard deviation and other parameters, statistics start to get more biased. But all you need to remember is don't sample more than 10%. That is the 10% condition. The third condition is the success-failure condition. Now, you might be a little tripped up on how to get the success-failure condition right here, because if you notice, you need to check NP and Q. Now, what NP and NQ are expected successes and expected failures. We aren't given the expected amount of success here. What we've seen in the past, it might say past research indicates that 70% of households will have internet. So to check that right here, we need to bring up our handy dandy calculator and go to 70% of, and we need to do 560. This is the NP-NQ condition. And N is equal to 560 because that is successes, 420, plus 140, which is failures. These are the people who answered yes and the people who answered no. So we go ahead and check this right here as I accidentally scroll down. We go ahead and check this right here and hit enter. And we get 392. Now that 70% I made up was just a number that I said the problem could tell you. It could say, we've seen in the past that 70% of households have internet. So with this in mind, if it were to give you a number we believe to be true, the proposed or the true or the hypothesized proportion, we would check using that, using the NP-NQ condition. I've checked NP, and to check NQ, I take 0.3 times 560. Once again, that 0.3 comes from the complement of 0.7, and these are numbers I'm telling you could be used in a test problem that we'd give you on this coming test. So we checked the three conditions, which in this problem was already done for you, but you might have to do that on the test. So once again, the conditions were the randomization condition. We have randomly selected people. 10% condition, less than 10% of the population was sampled. And the success-failure condition, there are at least 10 successes, at least 10 failures, denoted by the math equations NP greater than 10, NQ greater than 10, and solve for those like I did. Calculate the sample proportion P hat. P hat is the number of successes over the total number of trials. There are 420 successes over 560 trials. The trials is the total number of successes and failures as noted right here. Success doesn't mean we were successful in anything, it just means the yes which we are interested in. Scrolling down. Calculate the standard deviation of the sampling distribution of the sample proportion if the population proportion is 70. Now with this in mind, that's why I kind of use 70 for this problem. This is telling you that P is equal to 70. If you notice, P is the population proportion. That is very different. What we read right here says the sampling standard deviation of the sample proportion for P hat is equal to P times Q over N square root. So this is the sampling distribution of P hat. So let's go ahead and graph this right here using the David M. Lane applet. We can go ahead and put in our mean of 0.70, and then put in our standard deviation solved for in the problem. If you notice, what this graph is is if we go out and sample 500, and I believe it's 560 people, going out and sampling 560 people, here is what we would expect to see. We would get a value in here 68% of the time. We'd get a value in here 95% of the time, and a value in here 99.7% of the time. So it stands to reason that if we were to find 80%, this probably isn't true. Remember, this is what we believe to be true. The most likely thing to occur in this scenario, where 70% is the truth, is that we would find 70%. It would be odd to find something of 80%. We'd say that'd be an outlier. That would be something very odd. So that is the sampling distribution of p hat right there, described by 0.70, which is our expected, our population proportion, the mean, what we expect to see. Once again, take a look at this, and you see 0.70 here at the center. We don't expect to see the sample. The sample is just what we observe. What we expect is the mean, and thus we use what we expect to tell us the standard deviation. If you notice, this is constructed off of p, not p hat. Be very careful. A lot of people will put p hat in here, and it will make this wrong. Finally, the last question on here. This survey was conducted over a 1-week period by research volunteers who had given a list of residential phone numbers, landlines. Who might have we undercovered? There's tons of people in here that we could have missed. Obviously the homeless, college students, a lot of people don't have landlines anymore. Generally, when you get to a question like this, write as much as you can, but don't write craziness. Try to make it relevant to what we ask. I think this was a very easy question for most people. So my final thoughts on this question. Well, this is a chapter 15 problem. With that in mind, you need to be able to use this information given to you, especially in the second part right here. This part of the problem is very key, highlighting it right there. Being able to take that information and draw out the distribution of p hat. That is really not stressed in this version of it, but on the test or anytime using this, you might have to do that. This p hat would be plotted on here then, and we could ask something like, what is the probability of getting results this high or above? And if you notice, I'm plotting it right here. Now on the test, you might have to estimate that area. So take a moment, and using the empirical rule, we can notice that 0.75 is about 2.5 standard deviations above. Well, how many standard deviations is it actually above? What we need to do is observation, I'm clicking on the observation right here, 0.75, minus mean, right here, 0.7, divided by standard deviation. That once again is observation, which is p hat, write this down as I say it if you like, observation, p hat, minus mean, p, over standard deviation, right here. So we can do this. The z-score for it is 0.7 minus 0.70. That's just the distance it is away, 0.75 to 0.70, the distance, and then we're going to put it in terms of standard deviations. Oops, and I typed something in wrong if you noticed. I looked up and saw it. So let's rerun it again. And we have 0.0194. As we said, about 2.5. Now this z-score right here is 2.577. We can't figure out the exact area, but we can guesstimate it. And let's use the empirical rule. So we know 95% is between -2 and +2. 99.7 is between -3 and +3. That leaves outside of -2 and +2, 5%. That means outside of this is 2.5. Review chapter 5 if you need, but the empirical rule will let us estimate 2.5% is above here. Now, right here is 99.7 in between negative and +3. That means 0.15 is on the outside, 0.15, because we're left with 0.3 on both sides total and 0.15 left on just one side. And I believe we're going to see, since it's greater than 0.15, does everyone see that? Greater than 0.15, but less than 2.5. And this answer right here will be very close to, if I'm not mistaken, 0.005. Let's take a look at it. That's it. And that was a good guess on my part, 0.005. You would not need to get that close on the test. You could simply say it's greater than 0.15%. This is 0.5%. Greater than 0.15%, but less than 2.5%. And using the empirical rule, we can get that. So that's some of the concepts for this question right here. I've gone more in depth, but make sure you understand this question and how to use it and the knowledge behind chapter 15. Good luck.